You're listening and watching to Inside iOS Dev. Today with you, your host, Alex Bush. And I have a very special guest, Franz Busch.
Hi, great to meet you. Great to be on, Alex.
Last name is the same. We're not related. Just wanted to clarify, we're not brothers or anything like that. But Franz and I, we chatted uh, on Twitter. I think that's how we kind of met,
Yeah,
right?
I think that's how it started.
Yeah, we chatted about architectures and specifically about rib architecture. And what it turned out that France, and I think it was right at the time when I left Uber, when my contract with Uber ended, and I was sort of in the midst of making my ribs video course, which I unfortunately haven't finished yet, but and I was kind of sharing some thoughts and some code and stuff on Twitter. And I think Franz, you kind of saw it, and that's how we start to chat. And then it turns out you actually do use ribs yourself at another company where you work at, right?
Yeah, exactly. So back at the time when I reached out to you, I was gathering all the information because I'm leading the iOS team at Sixt, and we were actually looking into different architectures that we can use for our application to scale better for larger teams. And I saw your content and was really curious about your experience, and I think that's how it all started.
Yeah, yeah. And what's interesting, we kind of kept in touch for the last year or two, I think, at this point. And yeah, it's it was so funny and great to sort of see your perspective on all of this and your experience with ribs as well at not an Uber project, right? Not at Uber, because like before I would talk about ribs with other Uber people, right? And of course they're all on the same page, we're all on the same page, and we're kind of speak the same language, quote unquote, right? And it's all clear where we at. But then you coming from a different company, different perspective, but then having the same sort of, actually the same perspective on it, right?
Yeah, I mean, the problem that we were facing also was that while we thought the RIP architecture is great, it was very hard to get information because there was a bunch of videos, documentation, and also blog posts from Uber. But this was on a higher level, and we really wanted to dive into how things are going with dependency injection, how stuff is around handling map interactions, right? And this is where I try to get as much information from people out there in the community. And I think nowadays, actually, we also arrived at some of the same decisions that Uber did in the end, just from how the framework of RIPS makes you do certain things.
But let's dive into that as well. But
Sure.
before we do, maybe a little bit of a context from you on why even do it's like why did you even consider ribs in the first place, and then ended up kind of choosing it and going with it with your team.
Yeah, sure. So we did a rewrite of our application around the mid of 2016. And back then, Swift was still fairly new, and we basically just went with an MVC application. Later on, it was decided actually that we merge another one of our applications inside the first one, our primary sixth application. And at that point, we basically had two different architectures in the app. On the other side, also, we were rapidly growing. So we were doubling up on developers every half a year in the team. And we saw that the normal MVC kind of style was not working anymore. A lot of people were just doing things how they were used to in previous companies or how they thought it was right. And then we ran into all various kinds of problems, right? Stuff couldn't communicate with each other, stuff couldn't interact or even open other screens. There was a bunch of hacks just local to specific flows. And we basically saw that if we want to keep our pace up and really deliver a really, really good mobility platform out there, we need to have a common set of rules and a common architecture, definitely, to scale our processes and keep our developer experience and speed really up.
Yeah, it makes a lot of sense. And I think, as far as I know, this is how, sort of in a similar fashion, that's how Uber got to the same kind of conclusion, right? what was do you recall what was the kind of team size in the beginning? And then you said you guys kind of start to double, and at some point it would just be impossible to work with MVC, right? Do
Yeah,
you
so
remember what was the head count?
yeah, so funnily enough, when I joined, actually, we were three iOS developers, actually maintaining two and then three applications later on. And by the time we noticed that problem, that was probably something like 1.5 years in, and we were around only 8
Mhm.
developers working on a single application. But nowadays we are close to 30 to 40 iOS developers, and we are rapidly growing nowadays. So we already knew that at the point of around 8 to 10 developers on the iOS application of Sixt, we need to invest into the architecture to allow us to be 40, 50, and maybe 100 in a couple of years.
Yeah, that's actually interesting. You guys kind of felt it even earlier than at other places or at Uber, right? I think with Uber it was like 25-ish when they just could not do anything with MVC and had to reinvent it. Or
Funnily enough, I think there is one common thing between Uber and Sixt, and I kind of believe also this is where the need for this arises, is these kind of mobility applications that both of these companies are building always interact a lot with the map, right?
Mm.
And interacting with the map is just super complicated in MVC if you want to split it up, because you just always have one single view controller. And this is also where a lot of the other architectures that we investigated failed, because we always were bound by a view controller in the end. And I think this is where Uber was coming from, and where we definitely saw this is something that could solve a lot of our problems with MVC, where we did the map handling, massive view controllers, where all the orchestration around the map and bottom sheets was going on.
Yeah, right. And this is where Uber Ribs architecture blew my mind. And so what you just mentioned, the sharing, or sorry, how do I rephrase it? Every other architecture but Ribs would come at it or come at the problem of solving the architectural structure from the perspective of the view. They will be all view driven. And then Ribs was the only one where view is optional and it's actually headless by default. And if you want, you can have a view.
Yeah,
So
exactly. And that's also one of the most complicated concepts about that architecture, to understand how that actually works. And I think it blows everybody's mind. And we also had to write a bunch of onboarding documentation tutorial for people to understand what a viewless RIP is actually doing and how
mhm.
it works.
Yeah, right. Because like, think about it. For us, iOS developers, right, or just like client side developers, doesn't matter you do Android, iOS, or even like JavaScript front end. You, by definition, if you think about it, by definition, you do have the view. You need to render your stuff somewhere, or at least that's how we typically think about it. But Ribs flips it upside down, which is, I think, proper just for any type of software to do, where it's like, no, you have a main function, essentially, quote unquote, right? Of course, we can't have a main function in iOS, but it's equivalent of like app delegate or whatnot. And then you start your app there without a view, really, but you can have it if you want to render.
Yeah, exactly. I think basically the turnaround of not thinking view based but thinking state based is what really allows you to write your code in a proper fashion that transforms the business requirements into actual code requirements, where you're not trying to fit it into some kind of MVC, MVVM, or coordinator pattern. And the thing we were struggling with before, and that I saw a lot, was basically we knew exactly where to put code like networking or other internet-based communication things somewhere in a service layer stack, right? But it was always difficult where to put the business logic code so that it is reusable and also flexible. And now with RIPS, I think we completely solved that.
Right. Okay. So I think what we need to do now, so for our listeners and viewers who are not familiar with Ribs, kind of give a brief overview and show what Ribs architecture is all about, right? Even though, I mean, we just talked about it. I think the best would be to show GitHub, right? Uber Ribs GitHub. I think they have some diagrams there. So let's do that.
Yeah.
So guys, yeah. So this is how I'm in the Uber Ribs GitHub repo. Basically, this architecture is open source, right? And it's unlike first, I guess, thing to note, unlike other architectures such as Viper or coordinators or whatever else is like larger, like Ribs and more or less popular out there, they all of them are a set of guidelines, if you will, right? There is no framework, there is no code behind them. They'll just give you a bunch of articles or whatever tutorials, and you go do it yourself. With Ribs, there is actual code, there is an actual framework behind it, and it gives you things to inherit or protocols to adopt. And it does some work behind the scenes, right? For I think, what was it, the counting references or memory management stuff?
Yeah, exactly. I think if we go through the various components, we should talk about what actually the framework does for them.
Actually, yeah, we could do that. It would be very interesting. But before we proceed, you guys, I highly recommend everyone to kind of visit the repo and go through wiki specifically, right? It outlines more of what we were talking about and goes deeper into reasoning of why and what's the goal of the architecture and all of that stuff. But what we wanted to show is super briefly Ribs, right? What it stands for: router interactor builder. So you have a collection of those three objects composes one rib, and your entire app is a tree structure of ribs. And when you need to, and Franz, by the way, correct me if I'm wrong, it's been a while since I explained this stuff. You probably have more experience lately.
All good so far.
Yeah, but essentially it's a state management tool. Each one of the rib components has state and is responsible for one portion of your application, right? And in case of like what we're seeing right now, if you're logged out state and in onboarding, right, that's handled there and has its own respective kind of rib collection of a router interactor builder responsible for that, and a view and a presenter if needed to draw the UI. And then when the user progresses throughout your app and opens different screens on enables different features and stuff like that, other ribs responsible for the state management and kind of behavior of those parts of the app are attached to the tree of your rib tree of your application, and do their work essentially.
Yeah, I think what's important to mention here is that basically the tree that is built up is solely built up on the router. So you always have the one router in your application, right? And from there on, every router has n children, and you just attach these children to the parents, and the parents detach the children when state changes are happening. And basically, if you print the children of the children transitively, you get a representation of the live tree of your rib hierarchy during runtime, which is super great to see.
Yeah, that's kind of what they're trying to illustrate in this GIF, I think.
Exactly.
The grayed out ribs are those that are not in memory currently, but where your application path could lead to, right? And the darker ones are those that in this moment of time, right, when the user goes to this request confirmation part of the app, that's the tree that's currently in memory and enabled and state that's managed.
Yeah, and I think what you're saying here is super important to understand with this in memory thing, right? It really makes sure that your memory footprint of the applications is kept to a minimum, right? Even though the framework instantiates a bunch of objects, right, which makes it a bit larger than MVC applications, but it really is super, super specific that only things that are needed are in memory. And I think this is one of the first features that we should mention from the framework is actually, if you are detaching a children, the framework actually has a couple of things running in the background that looks that the ViewController of it's there is getting deallocated, the presenter is getting deallocated, and the router and interactor as well. So it makes sure that if you during development, you don't have any memory leaks. And that's super helpful. We found hundreds of memory leaks during development with this capabilities of the RIP framework.
Yeah, yeah, that's true. I kind of forgot about that at this point. But so let's talk about individual ribs, though, sort of more in detail of each part of the rib. And I think, Franz, you're probably a better person to explain this, as you kind of mentioned that you in our pre-call conversation, you actually onboard engineers quite often, on your team, and have to explain this, right?
Yeah, sure. Let me give you the quick onboarding rundown, basically. So normally a RIP consists of the router, interactor, and builder, like you said before. I think what I always start off actually is with the builder, because it's the simplest component of all of them. The builder is really just a connection tool between the dependencies. It gets all the dependencies and puts them into the router, interactor, presenter, or ViewController in the end that needs them. So after that, it's finished, right? And doesn't do anything more. And it also shouldn't do anything more. For us, actually, we are never writing tests around the builder because it's just hooking up dependencies.
Yeah, it's essentially, quick comment. Essentially, builder becomes like a factory.
Yeah.
If from a pure design pattern perspective, the name is not, the name is a builder, but it doesn't mean it's a builder pattern. It's actually just a factory that, as you said, produces those objects.
That's true. Yeah, the next one is the router. And I think this is where we talked earlier about this tree, right? And the router is basically the node in the tree in the end. And the only thing the router should actually do is build the children with their builders, attach them, detach them, and then also tell the view controller, if it has one, how to present it. So if it should be presented modally or it should be pushed into a navigation stack. And there should not be any conditional logic in routers, as far as I'm concerned, because it really only knows how to get to the next screen.
Mm-hmm.
And then I think this is now the most important part about any RIP, and this is the interactor. We probably spend a bit more time later on what the framework gives around that, but I always call it the brain of every RIP. It has all the business logic in there. It knows how to do service calls. It knows how to listen to updates in the streams of the application. And then it basically also gets the inputs from the view if there's anything, like if a button was pressed, and it then makes the decisions also what happens. So if a button is pressed, should I route to a children, or if a button is pressed, am I finished and I'm telling my parent I'm done, or should I do a networking call? So it's all the brain and also the thing that needs to be 100% tested, right? This is actually the thing that is making your application work.
Yeah, this is where the useful to the user stuff actually lives, right? You could call it a use case, I guess, if you're sort of coming from Viper/clean architecture perspective. But yeah, as you said, this is the brain. This is where all the good stuff happens, really.
Yeah. Yeah, and then the last two are the optional ones, right? The presenter, actually a super interesting component, because the idea behind the presenter is that you get certain domain models from your service layer, for example, that needs to be transformed into view models, because you, for example, need to transform a date to a string, right?
Mm-hmm.
Funnily enough, for us, actually, at Sixt, we have 0 presenters in use, because the guidance that we have is only for very, very, very large screens. You would need a presenter. Otherwise, you can do it in a view. And so far with RIPs, we were able to keep the screens and the RIPs very tiny, so we didn't need it.
Yeah, but one quick comment on this, though. Technically, though, inside of the RIBs framework, the framework provides you interfaces and classes to subclass from for each one of these parts, right? And inside of the framework, there is a separation between two different types of interfaces. There is a presenter interface, and then there is a view interface. And what happens actually is that the view controller adopts both and plays the role of the presenter and the view. But this is intentional. And actually, historically, originally RIB started with splitting those two in between into two objects, right? So there was a standalone presenter object and standalone view object. And what exactly what you were saying, Franz, like presenter would map stuff from models onto view models and tell the view to display it. But that's exactly what they found, that this thing is just typically most of the time is just too slim and dumb and doesn't do much, and it all can be safely merged and put most of the time into the view controller. And that's what happened. And in only rare cases, exactly what you were saying, in very, very rare cases where the logic is too complex for the presenter, it gets extracted out as its own object. But that happens like once in a blue moon.
Yeah, exactly. So I mean, if we talk about the view, right? The view is basically your view controller in iOS, and the thing that it does is basically it just gets a present call from the interactor most of the time, or from the presenter if it's there, and then just updates the UI and renders it. What we do sometimes is actually declaring view model structs inside the view controller, where we basically then get the domain models, and in convenience initializers we map the domain models to the view model, but also again to that only if it's larger. If it's very small, you can just extract the property out of the domain model you get and put it into the labels text. I think what is super important here, and is something interesting that also Uber came to the conclusion, as far as I know, is that we are not doing any reactive programming inside the view, right?
Yes.
This is something we didn't mention so far at all, right? But the whole RIP architecture is evolving around reactive programming. So this one here is actually using RxSwift, the open source implementation of Uber. We internally have our own fork, which is using Combine from Apple. But the most important thing is basically no reactive programming in the view, because the performance of these reactive hooks into UIKit is not super good and actually makes the application slower.
Yeah. Yeah. And sometimes I think what I've heard at Uber, they had an issue where it would lead occasionally to two-way binding, because sometimes developers just not careful and the data flow just gets messed up, right? So also to avoid that, they kind of prohibit having any reactive binding or anything like that on the view layer or presenter layer, right? Okay, so but otherwise though, without binding on the view layer, there is reactive data flow is managed through a reactive framework. And as you were saying, Franz, by default it's the Rx Swift, right? So because this framework was created before Combine was a thing, but apparently you guys even managed to fork it, right, and use Combine instead.
Yeah, exactly. I think basically when we made the decision to go to RIPS, we had a super lucky timing that Combine was announced by Apple. The problem was also that we had to support older versions which didn't support Combine, right? So what we actually used was a open source re-implementation of Combine. There are two, Open Combine and Combine X, and we used Combine X actually for a year in production until we were able to drop the minimum version of our application, and then we switched to Apple's Combine. And we're super happy that we could make the decision and not introduce RxSwift to our application. But it's fair for Uber, right, to use it because they probably have to support older versions than we do.
That's true. So how does the data flow work in a RIBS application then with I guess, not with RxSwift, but with a reactive framework?
Yeah, so I think we always have two kinds of data flows that we have to look into. One of the data flows is basically how how a RIP communicates with its parent, right? This is the simplest data flow. It's basically upstream. And here the RIP architecture is just employing a simple delegate pattern. They call it the listener protocol for a RIP, but it's basically a protocol with a couple of methods that you can define on your own, where you can tell what's happening to your parent, and then the parent interactor is implementing that listener protocol and can make certain decisions. So for example, if the logged out RIP tells its parent, hey, the user actually logged in, then the parent RIP can make the decision to detach the logged out RIP and attach the logged in RIP.
Right. And one thing to note there, that communication happens, right, on the more granular level between two interactors. So the roots interactor, or let's say, roots interactor in this scenario will be the listener of logged out interactor, and not the router, right? Not the builder, not any other part of the rib, but it happens from business logic to business logic.
Exactly, yeah. It's always that the brains need to connect with each other,
Mhm.
like in human cases. So I think this is one part of the communication and data flow pattern, right, which is the easiest one. And now the other one is the reactive communication pattern. And this is, I think, where RIPS is really, really good, because oftentimes you have something like the logged in user, observable, or publisher, right? And you have to get that into various locations, and all of them have to subscribe or observe that thing and then do certain business logic decisions. And normally the problems that you have both with RX Swift and Combine is that you get something like a disposable or cancelable back from the reactive programming framework, right? And you
Mhm.
need to make sure that you cancel or dispose that thing at the correct time. So normally, and what happens a lot in MVC applications that adopt reactive programming, is actually a bunch of retain cycles, because people are subscribing to these observables and then retain self in the subscription closures, or they just over aggressively use weak self everywhere to get themselves out.
Mhm.
And the RIP framework actually has a built-in life cycle, which is in every interactor, there is a did become active method and a will resign active method, that is handled by the framework itself, by the routers, to call it the correct timings. And there's conveniences on top of disposable, or in our case, on top of cancelable, where you can basically say in any interactor, you get a disposable and then you say cancel on deactivate. And what that does is you can use strong cells everywhere, right? And the framework makes sure that everything is canceled as soon as the interactor becomes deactive. That means also any network requests that were outgoing and are bound to publishers or observables will also be canceled, which is super nice.
Right. Yeah. Yeah, and we'll sort of dive into the particular implementations of that later, I think. But to kind of circle back a little bit to the data flow as well, um, the what you described, that communication with observables, right, to top to bottom, right, from the parent to children,
Mm-hmm.
is one-to-many communication always, right? It could be one-to-one if there's only one child, or if there's several children ribs, then it's one-to-many through that observable broadcasting, right? It could be via Combine or X Swift or whatever you have. And then that communication back that we talked about in the beginning, from from child to parent, that's always one-to-one, right? And that way the data flow is enforced. It's, I guess it's one-way data flow, right? That's how they describe it.
Exactly, yeah.
Yeah, and that helps you prevent a lot of sort of confused state situations that other applications have, that do not explicitly address and think through how the data flow is supposed to go, or where the data flow could go various directions back and forth. So roughly speaking, for example, if this, imagine we were in logged in rib, right? And then we attached three ribs at the same time, request, menu, and on trip. They're siblings of each other, right? And in order for that, each individual one of them can communicate on one-to-one basis level back to the parent. um, and then the parent can broadcast, let's say there's the same piece of data that all three of them need. I don't know, like users online status, if it's a chat application, right? To display that little green or red dot of being online or offline or something like that, right? That broadcasting would happen through observables from the parent, right, down to everyone who's interested, in this case three ribs.
Exactly. And also it can happen to children of children, right? So it
Yes.
can go very deep, and that's super awesome, because everybody can just subscribe to these updates and make sure that your application state is actually synchronized with your view state in the end.
Exactly, yes. And that gives you one single source of truth,
Yeah.
right? At that level where you create that observable, that usually, I think the Ribs framework doesn't bring that convention, but in the Uber's code base, they call them, oh man, actually now I'm blanking out. Something like
Streams.
storage, stream. Thank you. Yes. Um, which essentially was an object that either would persist stuff to memory or not, or maybe keep it, persist stuff to disk or keep it in memory. But either way, what it exposes as a public API is an observable, right? And as you said, anyone could subscribe to it anywhere down the tree, right?
Yeah, we have the same setup. Basically, we also have streams where it's just it's a protocol with a bunch of properties that are basically publishers or observables that you can subscribe to. And then we also have services, which are always basically coming together with streams. And the service object is basically the thing where you can call stuff like login user, logout user, and then it does the network requests and updates the stream. And we are making sure basically that there is only a single place in our whole applications that's responsible for updating a stream, and also only a single place where that state can be observed from. So we never have mismatched states between RIPs.
Yep, yep. And that helps you with communication between children, siblings. It actually can't happen, right? You in that scenario, they don't know about each other. There's a clear separation, clear wall. They're isolated, right? And if let's say something that changes in menu and has to affect some data that's in the request, the way the data would flow, the user inputs here, right? Select something in the view, I don't know, text field or whatever, checkbox. Then on one-to-one basis, it will be delegated up to the parent, and then parent will broadcast the data change via one of the streams that the request or whoever else down the chain, down the tree is observing.
Yeah, I think you bring up a very interesting point here, which I see oftentimes being done in MVC applications where if you have a flow of navigation screens, right, and you push from screen to screen, really often in MVC applications, what is happening is that each screen is calling push on its own on its navigation controller optional property from UIKit.
Mm-hmm.
And then basically every screen knows about the next screen, right?
Yeah.
And that is always going to be end up horrible in my opinion, because in the end, if you need to have certain decisions where you go to one screen or the other, and maybe you have actually cycles that could happen, MVC doesn't handle it properly. And RIPS kind of forces you in a framework where your RIPs are always input output, right? And if you need to orchestrate a navigation flow, you mostly have a RIP that's basically orchestrating the navigation flow, and the children are just communicating back, I'm finished, or this happened. And then this parent RIP needs to do all the decisions around routing to somewhere and what is the next step. And it keeps you actually, or makes your code way more reusable, because you can take out the steps, reorder them, use them in different places. And that's something that there's really nice guidelines from the RIPs architecture.
Yeah, yeah, exactly. You can take, let's say, this whole request, like this individual rib, doesn't matter how many children it has, potentially might have, but you can take it and, route, like right now, you route to it from logged in rib, but you can actually route to it from, let's say, favorites over here, right, on the completely other branch of your application's tree, and it will work, right? Because it's decoupled like that.
Yeah, that's super awesome. And I think when we come to that, maybe we should talk a bit about how dependencies are handled in the original RIP implementation, because I think that's also a very important detail of any architecture.
That is true. All right. So, yeah, let's talk about the sort of more granular dependency injection. We just talked about the data flow in a Ribs app, but also it's very the way Ribs handles dependency injection is also clearly defined, unlike other frameworks, right? I think Viper does not address it at all, right? Assembly and dependency injection. And I think every other framework, now I think about it, or sorry, every other architecture, like what is it, the coordinators or whatever else, they don't even talk about it, right? They leave that to exercise to the viewer, if you will.
Yeah,
But Ribs
exactly. I think
does.
RIPS is the only architecture besides Swift UI, which we probably talk about a bit later, that does something or tells something about dependency injection. And I think why RIPS is doing it, and also why Swift UI is probably can do it, is because they both have something like a tree of
Mm-hmm.
views or ribs in that case. And you can think about dependency injection actually in ribs in two ways. So you always have the tree, and each node has basically two or one protocol, which is called the dependency protocol. This is the thing that is saying, what do you need as a rib to work? That dependency protocol is normally located in the builder file, and it is a really nice description about anything that that rib needs to work. And if you can fulfill these dependencies, you can basically attach that rib as your child. On the other hand, there is this struct, or I think class actually, that is called component, right? And the component is saying, what can I expose to my children? And it's basically, you say at a certain rib, you have a component, and in there you instantiate a given service. And from that moment on, that service lives, and you and any children of that rib can basically use it. And that makes it really nice because as soon as you deallocate a rib, right, you can also make sure that every service or every dependency that is inside this component is also going to be deallocated. And it completely goes away from singletons, global objects, or anything. It makes sure only the minimal memory footprint is there.
Yeah, that's a great point about singletons, and the reason code bases usually have singletons because what they really want, they don't want a singleton, they just want a single instance of something, right, to be shared across in multiple places in the app. Uber like ribs enforces that through what you just described, right, through sort of having these component objects that are sort of satellite to each builder, right? They will be present in each rib that you create, and they will be the resolvers, if you will, of your dependencies. And they'll do two things. They will either your as builder builds every part of this rib needed, right? At least router and interactor and maybe even view and presenter, view/presenter. It will ask component to resolve the dependencies and get them somehow, right? And that's what component does. It either creates that object that this rib depends on, or it will ask its parent to get the object, right? And you kind of have the same cascading tree situation. Let's say, as an example, this favorites rib depends on two things. For example, on trip stream, and then depends on networking client. I'm making it up, right? Or networking service. So most likely, um, um, networking service will be the one shared across the entire application. Every other rib would want to use it, right? But then on trip stream is probably only needed for this portion, right? This on-trip location editor and favorites. So what happens when you instantiate, or rather build, I guess, a new favorites rib, the component builder there will ask the component, hey, I need this two things. I need this networking service and I need this on-trip stream. The component there doesn't know how to, or rather shouldn't be instantiating those objects. So instead it will ask the parent, location editor rib. Same logic happens there. The component there will try to resolve it. And it seems like this is not the appropriate place to instantiate either one of those. So it will ask its parent. And then on trip, this is likely where on trip stream is going to be created, right? So this will be in the component of this rib. We will actually initialize that streaming service or stream object, and that's what's passed down to those two. But then for the networking, right, service, this is again not the place to initialize it because we want to have only single networking service object throughout the application. So then it again bubbles it up and defers the decision making to logged in rib, its parent, to get it, right? And most likely, same thing here. It doesn't know how to make it, or it shouldn't be made over here. And then it eventually gets to the very root of your application where you resolve those high-level dependencies, such as network and service, right? And that way it can be shared through with other ribs, with all of them, because each one of them will go through this process of like, hey, component, give me dependencies, and then component either initializes it or requests it up from the chain.
I think what you just described is really awesome, because normally what you have to do in the standard RIP framework that is there in the open source project, right? You have to implement this, going to your parent, getting it from there for every single thing. So this is something where the RIP framework that is standalone is kind of lacking in convenience, because if you have a larger application, right, you sometimes have to pass down something like the networking service 20 or 30 RIPs deep and have to write a lot of code around that. And I think there is a tool that Uber also created, which is called Needle. And this is, I think, a truly unique tool in the iOS development, because it's basically a static code analyst tool that looks into these dependency and component protocols and classes, analyzes the hierarchy, and then makes sure if I need a dependency somewhere, how can I get it from what parent component, and automatically does all of the wiring. So you don't need to write any code. You can just say, what do I have? What do I need? And the needle generator basically makes sure to get it, or it tells you, hey, this cannot be fulfilled.
Yeah, exactly. So, sort of the big problem with this approach of, or rather disadvantage, let me put it this way, right? Because this approach of dependency injection is fantastic conceptually, because it makes everything so clear. It's like, it's just crazy obvious. Oh, okay, to use this rib favorites rib, I need 2 dependencies. That's it. Like whoever wants to use it, supposed to fulfill it whichever way, and that's it. Then you can use it, right? But the downside, what you were describing, the boilerplate, where you have to do it in 20 freaking places, right? And go up at that chain, and it's so annoying. And very reasonable to say, why the hell would I use ribs, right? If I have to write so much boilerplate code, it's annoying. Well, that's what this other open source framework that Uber made, Needle, it solves this problem. It basically will code generate for you so that you don't have to write that boilerplate.
Yeah, exactly. I think this is something we need to talk a bit more in detail, maybe in another episode, but this is truly unique out there, and definitely worth to spend some time talking about it.
And I think you mentioned that, I believe, doesn't have to be used with ribs either, right? So this thing actually, even if you have an MVC application or whatever else you have, you can use this Needle framework and kind of resolve your dependencies using it. It's fantastic.
Yeah. I think if I would describe it in one thing, it's basically a middle ground between manual dependency injection and the service locator pattern, but with all the compile time safety you want.
Yeah, exactly. Because like service locator pattern is great, but becomes, in my opinion, personal opinion, just too unwieldy and complicated too fast.
It also becomes super unsafe, right? Because your application just crashes if it cannot locate the services. And in larger applications, it's just not feasible to deploy something like this, in my personal opinion as well.
Yeah. And this will make everything compile safe. So if it basically, if it will compile, that means it works.
Yeah.
All right. So I think what we'll do, sort of the last part of this video, we'll show you guys an example of RIB's code base. It's one of the examples. The open source repo has several examples, and they have a tutorial, which is of course overly simplified, but it is a RIB application. And we'll show you only, I think, only maybe like the folder structure and one rib. And we'll have other episodes, because I think there's just so much to talk about where we'll dive deeper into it and maybe have a better example. But essentially, your rib application typically looks kind of, at least on the higher level, exactly like any other iOS application folder structure, right? You have your pod file or whatever dependency management tool you use. It's all declared here, right? And you have your Xcode project or workspace or whatnot, right? But this is where it kind of starts to differ. what they did here, and I'm actually very curious to hear, Franz, how you guys done it, because I think different teams at Uber did it differently as well. But the way it's structured here is broken down into folders for each one of these ribs, right? And each one of those, each one of those folders contains the collection of, well, router, builder, interactor, view if needed, and other objects related to this rib.
Exactly. So we at 6 at our scale, right? We have hundreds of ribs nowadays. And we also have a single folder per rib with all of the contents. But of course, we don't have it so simple like in the tutorial with only the main application module. It's our whole application is already modularized. But this is like an orthogonal concept that, of course, ribs supports as well.
Right, right. Well, yeah, and again, we need a sort of a better example, and we in another video we'll kind of go through it from the very start of like application app delegate and maybe and or scene delegate, how things kind of start there and you initiate your ribs tree and all of that. But for now, I think what we'll do, look at just one of them, maybe this random win, whatever that is.
Yeah, let's do that. That's a simple one. I think it's a good.
Yeah, it doesn't have much, right? Again, this is a view, what is it?
It's a viewful one.
Viewful. Yes, thank you. I was looking for that word, like headless, and what's the opposite? Viewful. So everything starts with the build. Well, okay, actually, Franz, maybe you go ahead and explain it.
Sure. So, like you wanted to say, everything starts with the builder, right? And what we talked about earlier, at the very top, always there is the dependency protocol where you declare what you need to work with, and the component class where you basically say what you have to work with. In this case, it's shadowing basically the dependency protocol properties. So this RIP doesn't declare anything that it can give to its children. But that's okay, right? It's a simple one. At the bottom,
wait. And a quick note: this boilerplate is what Needle would automate.
Yes and no. I think actually this boilerplate is basically gone if you use Needle because it does, or how is it called, a dynamic member lookup nowadays, where you don't need to write dot dependency anymore on the component. You can automatically go forward to the dependency protocol, a nice Swift feature. And of course, like you said, also Needle makes like some of that code way, way easier.
Right. But anyway, please continue.
Yeah, so at the bottom, there's this buildable protocol, which is basically just something that your parents are going to use, your parent RIPs basically, to instantiate that RIP. And then the concrete implementation here is actually, you see it's instantiating the component, instantiating the view controller, passing it dependency it needs the interactor, passing it the presenter and the dependency the interactor needs, then setting up the interactor's listener, which is basically the parent interactor, and then in the end setting up the router and returning it so the parent can attach that router to the tree.
Yeah, and I think this one, so you cannot navigate anywhere from this rib. And the reason I know it without looking into anything else is because we are not passing any new builders. We're not initializing any new builders and not passing them inside of this router.
Exactly. And the other place that you could see it is in the component class, right? Because we don't have any component properties declared. So that means there's no children. So both things basically already give you a great overview from the builder Swift file. You can see what are the dependencies, what does it give, what are the children.
Right. Without getting into any nitty gritty details of like actual business logic. Exactly. That's all in the interactor over here. And,
yeah, it's the public interface of a RIP, basically, and especially in larger organizations, right, where with tens of developers or hundreds of developers, just having this public interface for any given RIP makes it so awesome to collaborate.
And just to quickly contrast, we'll go through other parts of it, but just to quickly contrast this with another RIP that does have, navigation from it to some other children, right? The builder would look like this. The builder has what is it?
Yeah, it has the OffGame builder. Yeah.
Yeah. So specifically, you can navigate there, right? You're not passing the router inside of this router. No, not really. You're passing another builder that will build the next router as needed at the time when routing to this off game rib
And
happens.
that's super important, right? Because you pass the builder because of two reasons. So first, you can test that router then, basically that it invokes building this new child. And on the other hand, also it keeps the memory footprint low because you don't need that child in all of the cases properly.
Mm-hmm. Yeah, exactly. Exactly. But to get back to the random win one.
And now let's look at the router second, right? I would go with that one.
Mm-hmm.
So the router here is super simple, right? We talked about it already. There are no children, so it doesn't route to anything. So you see nothing is going on here. There's a interactable protocol, that's the default one where it defines the router and listener, a view controllable protocol, and then the implementation of the router, which is nothing. It's just subclasses from the viewable router of the RIP framework because this is a RIP with a view. Why there are two protocols is because you want to test the router also with unit tests, and you need these
Mm-hmm.
protocols for proper input-output tests.
Right. I think actually still kind of want to contrast it as well with
Definitely.
the more complex one like that logged in. So here you would have more stuff.
Yeah, exactly. Here you see actually we have already a method in the view controllable protocol, which is replace modal. Yeah, that gives you already a hint there's something going on with the view. And then of course, as we see, we pass the off-game builder inside here. And we have two methods basically to route to the off game or route to the game builder. And all the time here, we are detaching the current child, which basically says we are dismissing the thing that we modelly presented, right? And also attaching the new child, building it up, presenting the new view controller modally. And you can see it's a very nice interface to actually work with children because you attach them to the tree, you make their views visible, and then the children can go off and run on their
Mm-hmm.
own.
And another thing I actually kind of want to note here, and I think we didn't touch upon here as we were talking about sort of tree state structure of your application. What how this flips it on its head is that finally your own application is your own code is controlling the life cycle of your application rather than it being dictated by the UI kit and view controller specifically in any other architecture, right?
Exactly. This is what we briefly mentioned in these reactive programming
Mm-hmm.
things with did become active and will become active. And this is basically what is the result of this attach and detach call in
Yeah.
the router.
Yeah, and it always precedes. Well, yeah, essentially, it always precedes the actual view change, right? You first attach the new rib or detach, and then you do the UI change.
Actually, that's super funny. I would love to get your input on this one
Mhm.
because we at Six we actually do it the other way around. Also,
You know
always we
what? Now I remember. Yes.
because I think the thing that happens if you do it this way around is you attach your interactor, it goes off and does some business logic, wants to present something before the view controller is even on the screen, and then
Yeah.
nothing happens. So I think it should always be the other way
It's actually
around.
the other way. No, yes, stand corrected. Yes, I guess mm, I'm thinking about it that way rather than kind of conceptually that it's in control, right? But yes, you're right. We and present the view first, and it's actually should be in some sort of a the completion callback, right, for presenting the view. Then
Yeah, I
you
think it
attach.
depends. So we don't use this completion callback for presenting often because actually for us it works just doing it one after the other, but sometimes we have to do the completion closures and
Mhm,
also completion for dismissal.
mhm. Yeah.
Okay, the next one, right? Let's look at
Yep.
an interactor.
Yep. And the next
So the
one.
interactor, right, like we said, is the brain of the application. And here, what it does is basically it allows you to interact with, or it listens to what is happening on the screen. So we see there's a determine winner method, which is called from the presentable listener, which is actually this protocol in the view controller. No, not this one. It's actually in the view controller.
yeah.
So we will see that in a second. But so this is basically the user pressed a button and then we do some random win thing and we announce that winner by calling announce winner, right? Where we display something in the UI. And then we tell our parent through the listener protocol that somebody won now.
Yeah.
And here you can also see, I think that the methods are empty now, so did become active, will resign active, but this is the life cycle we were talking about. And you can hook into these places to do certain things like make your networking calls in these places, listen to streams, subscribe on them, and will resign active, you can clean up your children or do other cleanup tasks.
Yeah. If you can think of it to overly grossly simplify, this is your new view did load method, like sort of, at least where everything starts normally for an MVC application, right?
Yeah, I think view did load, and I think the great thing is also view did stop basically with will resign, which doesn't exist in UIKit. But the thing with the UIKit, right, oftentimes stuff was implemented in will appear and did disappear. And this often had some really unnice side effects. So this is only one life cycle that you have to take care of in RIPS is active and inactive.
Yeah.
Okay, let's look at the view controller maybe, or do you want to contrast it? Let's look at the
yeah, let's look at the view controller.
So the view controller, right, is like any given UIKit view controller that you have. You have an initializer where you pass the dependencies in from your builder that we saw earlier. And then in view.load, you set up your UI basically. And now you have to implement this presentable protocol that we saw in the interactor, where the interactor is communicating with the view controller, telling it that some winner is there. You can do your stuff like here, presenting a UI alert controller, even though I have to say, we don't do that, right? This should be done on the routers because you need to represent your view state with, exactly. So this is just a tiny example in the RIP tutorial. Normally it's done with the router. And then you have this build go button, which is setting up the UI. And basically here they are using RX bindings, but like we said earlier,
also,
don't do that.
Don't do that.
But basically on the tab, they are calling the listener interface of that view controller, which is communicating back to the interactor again. So this was, I think, a good overview, right? How a RIP looks. And you see basically between every part of a RIP, there is a protocol for the communication between the other parts. And basically everything communicates with everything except the view controller with the router. This is the only place where there's no communication, but the router, of course, with the view controller.
Right.
So, and the thing is, with all of these protocols in place, you can write unit tests for the router, you can write unit tests for the interactor, and you can write snapshot tests for the view controller real easily if you want to do that. And it gives you a very good confidence in shipping the code because you can test it. The builder makes sure that dependency injection is properly in place, and you just follow a good architecture always.
Yeah, it's one of the best or the best architecture I personally ever seen for the client side that follows solid principles and just good software architecture ideas so well.
And exactly. And the great thing that it does, right? It doesn't feel like other architectures that just forces you to split stuff for the sake of splitting it.
Yep. It has a kind of purpose, if you will, for each piece. And it also helps you at the same time because there is a framework. There is something you import, right? And there is things you subclass or adopt that kind of nudge you into that direction. So sort of making a mistake, quote unquote, and not implementing it or implementing it wrong is harder. Not impossible, but harder.
And I think this is one of the aspects why you want to adopt an architecture like RIPS, right? You want to give your developers a good guideline, a good framework that is still making them fast and also nudges them into the right direction so that you have an architecture that's similar everywhere and nobody's like breaking the boundaries here and there. And in the end, stuff doesn't work again with each other. So this is where RIPS really shines.
Yeah. Yeah. And I can attest in my own experience, I was working on two projects at Uber, and sort of both of them were implemented with ribs and sort of in a similar fashion, but it was the same team, right? So I thought, well, okay, we are the same team. That's why we're making things the same way. But then on several occasions, I had to help other teams from other departments, like completely unrelated to our stuff, and they also use ribs, and I opened their code base for their modules and their parts of the app, and it was pretty much the same, and it was so easy to navigate and start making sense of it.
Exactly. Yeah. The onboarding and the learning curve just at the beginning, it's maybe a tiny bit higher, right? You need to
Mhm.
get people to understand the RIP things, but afterwards they can work anywhere in the application all the time. They just need to understand the business requirements and not the technical requirements.
Yeah.
I think one thing that we should give as a lookout, right? Because probably a lot of people are thinking about that nowadays. We showed UI kit code. How does it work with Swift UI? I think we couldn't cover this in this episode, but as a
Mhm.
quick lookout, it does work with Swift UI. We had some experiments in sixth actually making this work. And there's also interoperability between RIPS with Swift UI and RIPS with UI kit. That's not an open source, but it's doable. And maybe we can talk about this in another episode.
Yeah, that would be very interesting, because I at some point when Swift UI came out, I thought, well, I personally am not a fan of Swift UI. I think it's a bad idea, but seems like that's where everything's going. And I thought, okay, is that a game over for ribs? But seems like, according to you, not really, maybe with some caveats, but you could use it, right?
Yeah, so I think what Swift UI does great is declarative UI, right? You are so much
Mhm.
faster in building your UIs, but stuff like dependency injection with the environment, which is basically a service locator pattern, or routing, which is super bound that you know all of your child um, views, is not so great for large applications. But this is where RIPS comes in and solves these things, and Swift UI comes in with solving building good UI and fast UIs, right? And both of them work very nicely together with slight adaptations.
Yeah, yeah, and it fits. Just one last comment on that, thought on that. It does fit well if Swift UI was properly done and how it should be. Your UI kit is really just here, right? Nowhere else. It's the rest of it is your own application, your own code, your own stuff that you control, and then UI kit or Swift UI or whatever else comes next is just this little layer, and hypothetically could be easily replaceable with the new thing.
Yeah, exactly. And it definitely is. And I think the thing that we want to achieve once Swift UI becomes a bit more stable is actually that we have RIPs that are based on UIKit, RIPs that are based on Swift UI, and they can just work with each other without a problem. The
Mhm.
framework is taking care to like map that stuff in between, and the rest just works.
Yeah, yeah. All right, Franz, this was a fantastic episode. We covered so much, and there's even more to talk about, specifically ribs. And we had actually in our show notes prior to the show, we had even more stuff of like working and organizing work in teams, and sort of doing requests for changes and other documents and proper process, which I think, we can have many more episodes, to be honest.
It looks like that. I think there's so much more to talk and so much information that we know from working inside larger corporations that I think we should record more and tell about our insights.
Yeah, and we would love to hear from you guys, listeners and viewers of this. Like, what are you? How's your experience been in small and large teams? What architectures did you play with? Do you want to give ribs a shot now or not? Leave us a comment in YouTube or on Twitter, wherever. And yeah, we'll would love to talk to you. Okay, friends. How can people reach out to you on the internets?
So people can reach me at Twitter at Franz J. Busch. And I'm always happy to hear from you what you think about this episode or discuss any iOS and Swift topics on there. Super happy to hear from you.
Yeah. And yeah, guys, as I mentioned, you can comment for under this video on YouTube. You can tweet at us at Inside iOS Dev or email at hello@insideiosdev.com. And we'll see you next time.